Hi everyone, here we have a GATE question for mechanical engineering which is from linear algebra. Here the question. Consider an n by n matrix A which is n by n matrix, square matrix, and a non-zero column vector of order n by n P. Their product, that means the vector, the matrix A and the vector P product is A into P, and which value is alpha square into P. So this is given, and alpha does not takes minus 1, 0 and 1. So based on the given information, the eigenvalue of the matrix A square is how much, right? So first let me establish a relation. So if lambda is an eigenvalue of an n by n matrix A, okay, and x is an eigenvector of order n by 1. Why? Because the matrix multiplication A into x should be make sense. So A is of order n by n, so x is of order n by 1, therefore A into x is make sense, corresponding to lambda, okay, corresponding to lambda, right? So therefore what we can write here is, so Ax is equals to lambda x. So we can establish this relation between eigenvalue matrix and eigenvector. So here lambda is an eigenvalue of the matrix A and x is eigenvector corresponding to the eigenvalue lambda. Okay, once again, lambda is an eigenvalue of the matrix A and this x is eigenvector corresponding to lambda. So in the similar way, let us compare the given relation. So the given relation is A into P is equals to alpha square into P, right? So which in the same way, so A is of order n by n and P is of order n by 1, and alpha square is a number and P is a matrix. So it is in the same fashion. So now let us compare. So alpha square could be an eigenvector of the matrix A and P could be an eigenvalue with corresponding to the eigenvalue alpha square. So P is an eigenvector corresponding to the eigenvalue alpha square. So therefore here I can write, so P is an eigenvector. P is an eigenvector, right? And what is alpha square? Alpha square is eigenvalue. That's it. So therefore alpha square is an eigenvalue of A. Okay. So therefore A into P is equals to alpha square into P, right? Alpha square into P. It means this alpha square is an eigenvalue of A, right? So therefore alpha square is an eigenvalue of the matrix A, right? What is the question? Here we have the question. Look at, so what is the eigenvalue of A square? I want eigenvalue of A square. So therefore eigenvalue of A square is how much? Let's have one property. So based on this property, look at here. If lambda 1 to lambda n are eigenvalues of an n by n order matrix A. Since order is n by n, that's why n eigenvalues are existed. Now the conclusion is lambda 1 raise k, lambda 2 raise k, up to so on, lambda n raise k are eigenvalues of A power k for any positive integer k. So A power k is a new matrix which is obtained from the old matrix A, but it is powered, raised power, right? So the new eigenvalues are again same old eigenvalues you take and you raise the same power, lambda 1 power k and lambda 2 power k up to so on. That means here indirectly a power k, the matrix a power k having the eigenvalue is lambda power k simply, provided if the matrix A having the eigenvalue lambdas. That's what the property indirectly. So if A having the eigenvalue is lambda, then A power k having eigenvalue is lambda power k. So by using this property, so eigenvalue of A is alpha square. So eigenvalue of A is alpha square, right? Now what is eigenvalue of A square? So power 2, right? So therefore here also for eigenvalue power 2 you have to do. So therefore alpha square whole square. That means which is alpha is 4. So therefore eigenvalue of A square is how much? Alpha power 4. Therefore option D is correct one. Option D is correct.